Dear students, our next topic is Wheatstone Bridge or Wheatstone Network. In this question, in this lesson, very important. Out of 100 percentage, nearly 33 percentage, this question is will ask for 5 mark. So, Wheatstone Bridge. An important application of Kirchhoff rules is the Wheatstone Bridge. So, Kirchhoff law one application only, that is Wheatstone Bridge. What is our aim of this Wheatstone Bridge? Total 2 aims are there. The first one is the aim of this Wheatstone Bridge experiment is to compare the resistance. To compare the resistance. The next one is to determine the unknown resistance. Suppose in network consists of number of resistance are there. So some resistance values are given. Suppose some resistance value are not given. So by using this Wheatstone bridge to determine the unknown resistance. So dear students, the Wheatstone bridge is one of the application of Kirchhoff law. Our aim is to compare the resistance and also to determine the unknown resistance. This Wheatstone bridge consists of 4 resistor of resistance, that is P, Q, R and S. Take 4 resistor of resistance and it should be connected in a network form. So see, this is the first resistance, the second resistance, this is the third resistance, this is the fourth resistance. So this is the resistance P, this is Q, take this is R, that is third resistance, this is S. Here total 4 junctions are there. This is the one junction, another junction, this one is one junction, this is one junction. So just represent, this is A, this is junction B, this is junction C, this is junction D. So these 4 resistance are connect. It should be like a network. 4 junctions are there. There is A, B, C, D. A cell is connected between the junction A and C. So this is a one cell. So the EMF, that is voltage of the cell, is taken as psi. So this battery, that is cell, is connected the junction A and C. You know, the cell is provide EMF, it like a voltage, it means they produce current. So that producing current, how to measure? But actually the current is measuring ammeter. So here this is cell producing a feeble current. So galvanometer is used to measure the minimum amount of current. So at junction B and D, connect one galvanometer G to measure the current. So connect one galvanometer the junction B to D. The current through the galvanometer is taken as Ig. The galvanometer resistance is taken as capital G, where G is the galvanometer resistance. Current through the galvanometer is taken as I suffix G. When the cell is on, cell provide EMF, it like a voltage, so it is producing current. So the current is going to this direction. This is the total current flowing through this circuit. So this current is goes enter the junction A. This current is dividing into two part. Again, this current is going to this junction, again dividing into so many part, and so on. So after that, this current is entering to this direction. So this I is taken as equal value only. When the current is entering to the junction, it is splitting. So here only the Kirchhoff law is valid. So apply Kirchhoff current rule at the junction B and D. Students, why we don't take A and C? So here the center part is B and D. So here only so many junctions are having. So Kirchhoff law is applied only the junction only. A and C also there is no problem. But here more junction is taken only B and D. So apply Kirchhoff current rule at the junction B and at the junction D is C. Apply the Kirchhoff current law at junction B. When the current comes, the junction is taken as positive. Then leaving the junction is taken as negative. See here. So the I is come to the junction A. I is dividing into C. This is I1. So here also going I2. Then this current is going to this one. Already IG is there. Okay. Then next I3. This current is going to this junction. Again I4. So apply Kirchhoff current law to junction B is, see the junction B, listen very carefully. Here this I1 is when the current is entering the junction, that is I1. But IG and I3 is after the junction the current is leaving. So you know the first law, algebraic sum of the current meeting at any junction is equal to 0. So that is current I1 that is entering, so it is positive. Listen very carefully. Then at junction B, again two more is there. IG is leaving, so minus IG. Then again I3, that is minus I3 is equal to 0. The next, apply Kirchhoff current law to junction D. See, apply the Kirchhoff current law at junction D. Here I2 is when the current is entering, so it is positive. But here I4 and IG also like entering, I4 only what? Leaving. So I2 positive, even IG also entering, that is positive, but I4 is negative, that is minus I4 is equal to 0. So this is taken as equation number 1. This is taken as equation number 2. Dear students, Kirchhoff current law part is over. Then Kirchhoff voltage rule. You know already, Kirchhoff voltage rule is applicable only closed path. So see the figure, A, B, C, D, A. This is one closed path. A, B, D, A. This is another one closed path. B, C, D, B or D, C, D, D, whatever may be. Total 3 closed paths are there. Here considering 2 closed paths. One is A, B, D, A. The other one is A, B, C, D, A. So first of all, applying Kirchhoff voltage rule to the closed loop A, B, D, A. You know the condition for applying Kirchhoff voltage law for any closed circuit, the algebraic sum of the current and resistance in a circuit is equal to the algebraic sum of EMF of the closed circuit. So here the loop is ABDA, that is ABDA. First of all, A to B, the current I1, resistance is P. So this is a arrow mark is like a entering. See, in generally we can say by applying Kirchhoff voltage law, for clockwise direction take as positive, for anti-clockwise direction is taken as negative. That means if the arrow mark is going like a clockwise means taken as positive, then anti-clockwise means taken as negative. So here the path is ABDA. AB, the arrow mark is like an clockwise, so it is positive. So I1P. See, ABDA, next to BD. BD also like an positive, that is IG for current. Galvanometer resistance is G. So plus IG into G. This IG for the galvanometer current, G for galvanometer resistance. Then ABDA, the last part DA, see the arrow mark, it is a anti-clockwise, so it is minus, that is minus I2, the resistance is R, so R is equal to 0. So put equation number 3. Then applying Kirchhoff voltage law to the loop ABCDA. So applying Kirchhoff voltage law to the loop ABCDA. Listen very carefully. See ABCDA, ABCDA. Here AB, that is I1P. Then BC, that is also I3Q, that is plus only, clockwise direction. Then CD, C, this is anti-clockwise direction arrow mark, so I4S, that is minus I4S. Then DA, this is also like an anti-clockwise direction, so the resistance is R, current is I2, that is minus I2R is equal to 0. So this is put equation number 4. Just rewrite this equation, that is I1P plus I3Q is equal to this minus is go to that side. We get I4S plus I2R. Put equation number 5. See the diagram. At junction B and D are at same electric potential. That time what happened? This network is balanced. That means there is no potential difference between B and D. That time the galvanometer shows null deflection. That time Ig is equal to 0. When the junction B and D are same potential, that time Ig shows 0 deflection, that is Ig is equal to 0. So this Ig is equal to 0 in substituting in equation 1, 2, 3. We get the 3 equation. After rewriting, Ig is equal to 0. That is I1 minus I3 is equal to 0. That means I1 is equal to I3. Put equation number 6. Equation 2, I2 minus I4 is equal to 0. That means I2 is equal to I4. Put equation number 7. Then this equation, I1P minus I2R is equal to 0. That means I1P is equal to I2R. Put equation number 8. Then dividing equation 5 by 8. So dividing 5, equation 5 divided by 8, we get 5 is left hand side, that is I1P plus I3Q divided by here in equation 8, left hand side is I1P is equal to equation 5, right hand side I4S plus I2R divided by I2R. Then just splitting up I1P by I1P plus I3Q by I1P is equal to I4S by I2R plus I2R by I2R. See, you know equation 6 and 7, I1 is equal to I3, I2 is equal to I4. So just rewriting, instead of I3 also put I1. So here this place I3 is replacing I1, that also I4 is also replacing I2. We get I1 cancelling. Instead of I3 is equal to I1, this also put I1. This one cancelling. I4 is equal to I2. Instead of I2 are cancelling. Then this one cancelling. The remaining is P by P, this also cancelling. R by R, this also cancelling. So 1 plus Q by P is equal to S by R plus 1. 1 also cancelling. The remaining is Q by P is equal to S by R. That is P by Q is equal to R by S. This is the condition for Wheatstone network. This is the last formula for Wheatstone network. Dear students, this is the formula for condition for Wheatstone network or Wheatstone bridge. That is P by Q is equal to R by S. You know, our aim is to compare the resistance or to determine the unknown resistance. Compare resistance or to determine the unknown resistance. See, by knowing the resistance value P and Q, we can compare to the value of R and S. Or suppose any one resistance is unknown, means by using this formula, suppose P is a unknown resistance, means P is equal to Q into R by S. So we can easily find the unknown resistance by using Wheatstone bridge. So my dear students, please, this is a very important 5-mark question. In this lesson, this question, then resistor, series and parallel, then potentiometer, that is next day topic, then microscopic forms of Ohm's law, then the carbon resistors, the drift velocity, mobility, that are the important questions. So dear students, study it.